When I used to teach freshmen, they would come in and in a little bit of a whiny voice ask, "Mr. Naylor, are we graphing today?" Well, you're not freshmen anymore, and the answer is yes. Graphing is just an essential part of algebra. It's not just one chapter, it's not just one topic. Graphing is part of algebra and becomes part, if you keep studying math, of other math courses. So yes, we are graphing today, and we'll be graphing all year when necessary. So do you remember how to graph an equation? Well, maybe the first thing is, do you remember what kind of equations get graphed? Recall that they have to be equations with two variables. When you look at an equation with an x and a y, that means that there are many numbers. There are many ordered pairs that will work for x and y. It's not just that there's one solution. So the truth is, the many ordered pairs, the many points, end up looking like a graph or like a line. Of course, it doesn't have to be a straight line. You'll learn more and more that the line certainly can be curved. So what do you think about these two equations? They are in the warm-up on the Nearpod. If you did not do the warm-up yet, you should do that. So pause the video. What do you remember about graphing? And then come back and we'll see how you did. All right, now if you did not do the graphs on Nearpod, you're not taking responsibility for your learning. So again, you need to pause the video and do the graphs. But if you did do the graphs, then it's time to continue. And so y equals 1/3 x minus 4. Now that kind of equation we either remember or will remember is in slope-intercept form. And that means that you have the slope and the y-intercept. Now recall that the number in front of x is always going to be the slope, and then the number that's being added or subtracted is the y-intercept. So when it comes time to graph that, all you have to do is plot the y-intercept on the y-axis, right? So we don't want to graph that on the x-axis. That means it's an x-intercept. And once you plot 0, -4 on the y-axis, then all you have to do is rise over run, 1/3. So I rise 1 and I run 3. So when you rise 1 and run 3, you'll be at a new point. You want to be able to identify that point. Graph paper is easier, but you can still count, and that would put you at 3, -3. So now we have 2 points, and 2 points, when it comes to a straight line are all that you need. So you can draw your straight line. Just remember that this straight line has many other points, and every one of those points is also a solution to that equation. Now the second equation is not in slope-intercept form because it's not y equals mx plus b. Now a lot of students will put it in slope-intercept form. That's kind of your natural reaction. There's nothing wrong with that, but I want to share that it's not necessary. In fact, it might make things a little harder unless you remember that you can solve this equation, you can graph this equation using what's called the x and y intercepts. Now the x and y intercepts are easy to find because all they require is that you plug in 0. When I say plug in 0, I mean you plug in 0 for one of the variables. And when you plug in 0, for example, for x, you're going to notice that that half your equation becomes 0, and so all you have to do is solve the equation for y. And when you solve it for y, which is pretty easy to do, you just divide by 4, you get the y-intercept. So that's what happens when you when you plug in a 0 for x. What happens if you plug in a 0 for y? Well, you're going to be finding the other intercept. You're going to be finding the x-intercept. Now the nice thing about plugging in 0 is that it causes part of the equation to become 0. Remember, that's because 0 times anything is 0. And all you have to do is solve for x, which again is pretty easy to do. Divide by 2 and you get the x-intercept. Now, remember, these two numbers that we found here are separately the x and y-intercept. So don't do something silly like put them together to be 1 point. That doesn't make any sense. Instead, you would want to take each point individually, and the first one we found was the y-intercept, the second one the x-intercept. Remember, intercepts are, of course, match up with 0, and that's why they were easy to find, and now we can draw our line. There's other points on the line. Every one of those points would be a solution to this equation. So, graphing equations 101. Let's just go back a step. Remember that when you have an equation in slope-intercept form, it'll have to be such that it's solved for y, and we call that y equals mx plus b. M, that's for the slope. Not sure why we use the letter m, to be honest, but it is standard. And b is the y-intercept. Maybe we should also remember that the slope is rise over run. That's a nice little reminder. Rise is up and down. Run is, of course, left and right. And then x and y-intercepts, that's when an equation is of the form ax plus by equals c. I didn't mention, but that is called standard form. When an equation is in standard form, the variables x and y are on the same side. But the nice thing about an equation in standard form is that you can use x and y intercepts in that you simply plug in 0. So for the x-intercept, you plug in y equals 0, and for the y-intercept, you plug in x equals 0. I don't know if that seems backwards to you, but it is true that the x-intercept, a 0 goes in for y, and for the y-intercept, the 0 goes in for x. So that's the way that they end up as intercepts. So what do you think? Let's graph some equations. Now, when you see this first equation, I hope that you pretty instinctively shout out slope-intercept form. Y equals mx plus b. -3 is the slope. 4 is the y-intercept. We want to make sure that we keep those two numbers straight. They represent the key components to that graph. Now, when it comes to the slope, right now, being a single number, well, we're going to want to think of it as a fraction, as two numbers, as a rise over a run. So -3 over 1. Okay, now be careful. The negative sign is only going to apply to one of the numbers. We typically apply it to the numerator, so we'll say -3 over 1. So the y-intercept is 4. That's where you want to start on the y-axis. And since the slope is -3, we'll count down 1, 2, 3, and we'll count over 1. Now notice that I counted in a positive direction for my run. That's because the negative sign only applies to one of the numbers. Again, typically the rise. Once you have 2 points make a line, and you're ready to draw your graph. Remember, the graph is the solution. That's because the graph contains many points, all which would satisfy that equation. Now the second equation, it's not in slope-intercept form yet. Okay, it's not in slope-intercept form until it's y equals. So that 3 right there, you want to divide it away. You want to do the inverse operation. Notice that I'm getting ready to divide everything by 3. That is on both sides of the equation. So now I get a y equals equation, but the rules of fractions would say that that 3 has to divide into the 2. It doesn't divide evenly, so we typically just write it as 2 divided by 3. But the 3 does divide nicely into the 9. That is the -9, so we will want to do 9 divided by 3, or -9 divided by 3, of course, comes out to -3. Now the equation's in slope-intercept form. You have your slope, you have your y-intercept. You should feel like that you can graph this. Are you starting at -3 on the y-axis? And are you going up 2 and over 3 to find your second point? Draw that line, and you just graph that equation. Slope-intercept form seems to be something that students are typically comfy with. What if the equation is in standard form? Now, if the equation is standard form, you could solve it for y equals. You could bring this x over here. You could bring this 2 over. There's nothing wrong with that. To be honest, I would like you, though, to consider finding the x and y intercepts. It's going to help you, I promise. It's going to help you in the future. So how do you find an x-intercept? You just plug in a 0, right? But you plug in a 0 for y. So when you plug in a 0 for y, of course, it's going to be 2 times 0. Now, hey, that disappears. If that disappears, if this entire quantity disappears, perhaps maybe you just want to think about covering it up. You just want to, so to speak, erase it. Well, when you do that, you get x equals 8. Listen, x equals 8 is your x-intercept. You can even graph that right now to make sure that it ends up on the x-axis. How about the y-intercept? The y-intercept is when you plug a 0 in for x. Now, if I'm going to plug a 0 in for x, then I'm going to end up with, well, I'm going to end up with that part of the equation disappearing, canceling out. As I said before, maybe you just kind of think about erasing it. The bottom line is you have a 2y equaling an 8, and if 2y equals 8, all I have to do is solve for y, nice little divided by 2. I can understand if you can do that mentally, that comes out to be y equals 4. That's your y-intercept. I'm going to get rid of those so they don't clutter up the rest of the screen, but y still equals 4. Now, if y equals 4, that's going to be the other point on your line. 2 points can be connected as straight as possible, and you have your graph. In class, you would see me cover up part of the equation. If I'm going to cover up part of the equation, maybe, just maybe, I can, let me see if I can do it here. If I'm going to cover up part of the equation, like plugging in a 0 for y, that just means that that part's going to go away. And maybe even mentally, you can just solve this by dividing both sides by -2. You get your x-intercept. It comes out to be x equals -6. The whole point there is that you can do that mentally. Let me erase that again so to not clutter that up. But I get x equals -6. Can you plug in a 0 for x? Can you cover up part of the equation? Now, what just happened there is I plugged a 0 in for x. I'm still left with -3, so I have to divide both sides by -3, but that can maybe even be done mentally to get -4. So I get y equals -4. I'm not much into shortcuts, but I'm offering that it's possible sometimes to find your points with just a little mental math. Make sure that you plot -6 on the x-axis and -4 on the y-axis so that you can draw your line. Now, each of those equations, we could argue were pretty either standard or common, but there are other equations out there that can still be graphed as lines. These do date back to Algebra 1, but arguably these are special. And what we want to do now is we want to think, okay, what are they trying to describe? If x equals -6 is a line, what that means is that every point on that line has to have x equaling -6. Now, I will see students instinctively go to x equals -6, but what you're really doing is you're going to a point that contains, whoops, I wrote that backwards, didn't I? You're going to a point that contains an x value of -6. What about this point right here? Does that contain an x value of -6? Well, it sure does. Now, it happens to have a y value of 3, but are you catching on that every point on this line, on this vertical line, is going to have an x value of -6? That means that that vertical line is actually the solution to an equation where we just have an x value. So what about if we have an equation that just has a y value? Now again, I will find students instinctively go to y equals 5, but what you're really doing is you're going to the point 5, 0. Boy, I'm having trouble with that today. Excuse me, that's the point 0, 5. What other point or points have y value of 5? How about this point? How about this point, this point, this point? Don't they all have y values of 5? They sure do. And as you look at the pattern of these points, you should eventually say that they represent a horizontal line. So when you have an equation where it's just y equals a number, that's going to graph as a horizontal line. So what about g and h? Well, I hope that you realize and notice that they have two variables. So when you have two variables, your solution will definitely end up being many points. Well, the reason I have g and h here is to make sure we understand that you can solve any way that you want, or I should say you can graph any way that you want. If you look at letter G and your instinct says that I want to make that y equals, hey, if you want to make that y equals, then go for it. Now, I hope that you make it y equals as easily as possible. Do you realize that subtracting 6 would be the easiest way to make this equation y equals? If you think the equation kind of looks backwards, well, just rewrite it or just rearrange it. You can put the y equals on the other side. Either way, it's y equals mx plus b. And you're going to town thinking about a slope that has a rise over a run, and of course thinking about a y-intercept of -6. Let's not clutter it up too much. You're just going to start at -6. That's -5, -6. And you're going to rise 3, 1, 2, 3, and you're going to run 1. So it gives us another point here. Now, can I rise 3 and run 1 again? Can I rise 3 and run 1 again and again? Well, sure. In fact, it's not a bad idea to remember that as you continue to rise 3 and run 1, that you're going to continue to be in that same line. So that was nice. What about if I want to graph this equation more like standard form? Okay, now standard form, again, most students say they're not as familiar with it, but standard form is when the x and the y are on the same side of the equation. So subtracting y from both sides kind of gets you ready for standard form. Now once I subtract y, then I have an equation that I'm going to argue you can pretty easily plug in 0. Now remember, if you plug in a 0 for y, you're going to find the x-intercept. Divide both sides by 3, and you get x equals 2. Bam, I got my x-intercept. Now if I plug in a 0 for x, I'm just going to get negative y equals 6. Now be careful, if negative y equals 6, that means positive y equals -6. Now these two numbers right here represent my x and y intercepts. And I just realized that I did that in blue. Excuse me, I did that in red. I kind of wanted to do it in blue. So let me just switch that. I get x equals 2. I get y equals -6. Because I want you to see that x equals 2 is going to produce, look at that, it's going to produce the same point. And y equals -6 is going to produce the same point. And of course, that means I'm going to produce the same graph. So you can graph it either way. Now somebody asked, do I need to know how to do it both ways? Well, I'm going to answer, in all honesty, yes. You need to be able to do it both ways is because you advance in algebra. Sometimes one way is easier than the other, and more likely sometimes you can't even do it with one of the methods because, well, because of the types of numbers. And you'll see, we'll get into that a little later this year. If you flip the paper over, we have 3 practice problems. So if you were in class right now, guess what you would do? Yeah, you would graph these 3 problems. You can graph them any way you want. And what I want you to do is compare them with a neighbor, except your neighbor's probably going to be me. All right, so push pause, and then we'll do a little comparing. We'll make sure that you have your graphs right. All right, how'd you do? Practice 1. It is meant for you to do an x and y intercept. So if you plug a 0 in for y, you get your x-intercept. Now if you plug a 0 in for x, you got to be careful. You get negative 2y equals 4. You want to divide by negative 2. And that's going to be your y-intercept. Make sure you realize it's y equals negative 2. Remember, those 2 numbers actually represent points. They actually represent intercepts. And this time I wrote my zeros in the right spot. So I'm going to go over here and graph them in the right spot. I'm going to graph 4, 0. I'm going to graph 0, negative 2. And I got myself practice 1, or equation 1. X equals 7. Maybe you recognize that from the front of the paper that that's going to be a vertical line. You don't necessarily have to write that. What I really want to make sure is that you remember that you want points that contain x equals 7. And there's a variety of points. In fact, there's an infinite amount of points that have x equaling 7. But that's why it ends up being a vertical line. Those points, definitely the pattern of those points goes in that direction. So that's going to be P2. And how about the last equation? If you decided to write this in y equals mx plus b form, then yes, you would have needed to divide everything by 2. If you divide everything by 2 carefully, the 2 divides into the 4. The 2 also divides into the minus 8. But of course, now we have our slope. Now we have our y-intercept. Make sure you keep the negative sign as part of your y-intercept. So we're going to plot negative 4, y equals negative 4. And we're going to rise 2 and run 1. If you rise 2 and run 1, you start to move in this direction. So that is P3. All right, give yourself the opportunity to practice. We've got some problems. Make sure that you do try number 12. If you glance down there, you'll notice that number 12 is not y equals mx plus b, and it's not an ax plus by, in other words, standard form. That's because it's got this exponent. Whenever you have an exponent, that means your equation is nonlinear. It just means that it's not going to be a straight line. So what are we going to do? You're going to fill out a table of values. And that table of values will help you see the points that you'll then connect.